screen. Okay, can you see my screen?
Yep.
Okay, cool. Thank you guys. So after many cancellations, back to our weekly meeting. First of all, just quickly go over logistics. So we had our KubeCon sessions. So I think the major topic was like multi-tenancy and also firmware verification, which we'll be discussing today. KubeCon China is approaching, so we do have one working group session admitted. I think the CNCF Security SIG will have other sessions, so we'll see what happened there. CNCF Security SIG is finally approved from all the procedure considered, and from Kubernetes side, we have stakeholders, so basically we can review KPs now, so just minor stuff. Okay, I think we can go over. So I think we can, let me just quickly go over as Erica and I did with Byron the other day, and we can sort of just jumpstart, like see how we should better proceed. Okay, would that work for you, Dan?
Yeah, sounds good.
Okay,
thanks.
Let me just present. Okay, so what we will be talking about today is basically to see how we can provide a way to like formally verified cloud native policies. So let me just give a quick overview of current like what cloud native policies are involved. So we did some case studies. Apparently there are a lot of projects that like hosting CNCF and also outside CNCF indeed heavily utilize policy or relies on policy. So I just picked three like the most prominent projects that are policy related. So first of all, Kubernetes, of course, as now more or less the de facto container orchestration platform. For Kubernetes, there are really a lot of policies. So for example, we have pod security policy, basically provide the basic layer of like policy isolation for the pod. We have network policy for ingress, egress. We have also CPU manager policy for hardware. And we have storage policy, which semantics are like more like return delete instead of like allow deny. And also we have multi-tenancy policy in the making. We have new proposals. We also have RBAC policy in Kubernetes. Yeah. So the second one is Istio, sort of now the de facto microservice framework. So for Istio, have like Istio basically a control plane, and they work with Envoy as the data plane. And in Istio, policy is mostly related to security. So there's a Istio security working group that focus on the security policy. So the most important one, like authorization policy, they are working towards version 2. which will start support denies semantics. They start with allow, like many other projects. And also they sort of evolve from the service rule binding object to a like unified defined authorization policy object. They have like selector, allow, deny, semantics. Also, there will be support exclusions, like more semantics. This is like example to, so when they apply authorization policy for ingress and egress control in Istio. So one of the things they mentioned also during their talk on the working group meeting is that now they they're having more and more complex policy. There's a problem of like conflict resolution. Say they have a bunch of allow, deny, how the priority should be formed. So the simplest way is to have like most of the IAM have like explicit deny versus explicit allow. So it's very easy to reason, but it's very rigid. Another way they are looking at just add like arbitrary order number to each policy, but it will be really difficult to scale out for this option. So they are still looking at like a better resolution. And they will introduce some of the expression conditions, logic, basically. Okay, the third one is open policy agent. Basically, the de facto policy agent in the cloud native world. So OPA like consumes policy that written in Rego, and also you have a data source, and services could do the policy query and also other policy related actions. So it's a pretty classical policy agent engine. So OPA utilize Rego for the policy definition, and Rego is some sort of a flavor or extension of Datalog, which is like already heavily used in the industry for the first order logic. Okay, that was like the most important three projects. Of course, we have many more that are using policy. So we did a couple of case studies from last year to early this year. So this is some of the takeaways. So we are seeing the trend of defining like unified policy objects instead of just the traditional like rule binding or having policy as just a subset of a configuration. Another one is the semantics will be more and more complex. Usually we have like allow deny will be like usable enough, but if you start look at like storage and many of the container security frameworks, they will have a semantic like match, or for storage will be like reclaim. So I think there will be like many more semantic actions or verbs will be supported or needed, and also we'll be possibly seeing some of the adverbs to describe the like the types of the policy action, strong or preferred. Basically helps solve the conflict resolution problem. So yeah, this is some sort of takeaway. So this is a picture we came out just for the time being. So we could have like control plane concept and data plane concept. Then we have the layer of policy control. We have the policy engine like OPA. We'll have a formal verification engine, probably many like SMT solvers or a combination of those. And a compiler in the sense that could translate the policy logic to the control plane logic. So in the context of Kubernetes, there will be the custom resource definition, CRD controllers. In the concept of other control plane, there might be other formats of compiler. So the things we are interested to discuss today. Motivation. So as we mentioned to Byron, what we are exploring is that whether it is possible to provide a formal verification for either cluster or namespace scoped policy, like in Kubernetes, both ahead of time fashion or just in time fashion. The main goal is first of all to prove these policies are correctly defined. So the policies themselves, and also to prove there are no conflict among these policies. And during KubeCon, we had like discussions with JP Morgan, and it seems like also coinciding with AWS automated reasoning groups use case that this is a big financial customer requirement. So I will skip those because so we are thinking like probably what we need to do is something like construct a symbolic graph for Kubernetes, but for each Kubernetes domain, because it will be different like from domain to domain, I guess. For networking, there will be like bi-directional flow, something like that. For multi-tenancy, there will be like how to populate the tenant, like the tenant privilege from the original roles to what the admin want for the tenant. So it also could be hierarchical. So for example, we have the quota concept in multi-tenancy. For security, basically it's like a parameter, so that'll be a layered reduced access sort of graph representation. So I guess for storage and many other domains, there will be other like different type of symbolic graph we could construct for policies. So what do you guys think, especially then what are your thoughts, like what could be the viable next step?
Yeah, well, so can I ask you a few more questions before? So let me, is your working group's goal to try to reconcile, or to try to come up with sort of a consistent framework for the various policy engines that you mentioned at the beginning? Or like, are you focusing on one of them? Like, I wasn't quite sure what the relationship is between like the various automated reasoning things you're talking about and those three. Like, are you focusing on the native policy thing, or?
I think we're trying to like consolidate the policy like across the field, but basically, okay. Yeah, basically we are now like starting with, for example, OPA as the default policy engine. Yeah, yep. so that we don't just start from nowhere. And
more and more Kubernetes it used to be about building these kind of things in, but now it's much more about being the common language and for your distributed system and having things
Yep.
plug into it.
Yep.
So at that point, we kind of want to look at the whole ecosystem, but from the perspective of the platform we provide for it through the Kubernetes API types.
I see. Okay, yeah. So like I'm just thinking of like, because the models of the different policy systems you've talked about are quite different. Like OPA is like being data log based is not going to be easy to reconcile with sort of the allow, deny, allow like precedence type thing and or the ordered precedence thing that you mentioned in one of the other ones. Like those are all quite different and seem hard to like come up with a common framework for dealing with all of them.
Yeah.
So like, are you, so if you're focusing on OPA, that means the other ones are sort of left to further work. Is that correct? Or
yeah,
one place that they all kind of tie in are, there are a few kind of enforcement points, like at admission time, or whether one of the defined interfaces, like the container runtime interface, the container network interface, the service mesh interface, one of those other ones. There's certain interfaces where you can act at admission time for the API objects, and you can define custom CRDs, custom resource definitions, which you are expected, those are kind of the shared state across any type of system and plugin. So Istio defines policies using a custom resource. The admission acts upon different admission of different resource types. Does that kind of make sense?
I think so. Yeah. So I mean, I played with Kubernetes some. I wouldn't say I'm at the point where all these things you've mentioned make sense to me, but I think I sort of get it. So the other one of the other questions I had was like you mentioned multi-tenancy policies. I'm just unclear on what that actually means. What does what kinds of things are being governed there?
The main ones are ensuring some kind of isolation. So that's the more standard.
Yep.
Some sort of self-service and scoped view of the world for different kind of users, so that, you know, one group can be doing their thing and creating whatever, running whatever workloads without knowledge of or interfering with someone else doing the same thing. And then the last one along with that is also resource management, quotas, quality of service, and that sort of thing. Those are some of the main places in that when we say multi-tenancy.
I see. Okay. And so is the initial focus on this reasoning step on any one of those in particular? Like most of the ARG stuff in Amazon has been focused on sort of security side of things. Both like it would apply to your networks, your network policies and your the security policies, but we're sort of thinking of them in similarly. But like, are you focusing on security policies, or are you trying to do all of them, or?
We can just start from just picking one of the area. I think.
Yeah. Oh, okay. Well, so what types of questions like are there? Is there sort of like a set of questions that you want to be asking of the reasoning engine? Like, I think that will also often shape like how you structure it. Of like, are they sort of like probing questions, as in like you want to fuzz the type of thing, or are you trying to say universal, like a universal invariant of like this is always going to be true for this policy?
Definitely the universal invariance and being able to validate that. Some kind of maybe easy things would be preventing any conflicting things, making sure there aren't escalations possible via certain policies or other aspects of dynamic nature.
And when you say conflicts, what does that actually translate to? Because like if you did have like it seems like sort of the conflict resolution is sort of built into the policy engine in some sense. So as in, if we go with the allow Trump's, I mean, deny Trump's allow Trump's implicit empty deny model, like AWS IAM follows, like if there are conflicts, one wins, and it's sort of well defined. Is that?
There's some kind of just arbitrary ways different policies do it. That's one kind of an annoying issue, as well as there is some timing issues, and that I'm not sure that we're well aware of how it handles.
Okay. Can you elaborate on that a little bit? I'm just trying to sort of peel out the types of things in the space.
Yeah, I'm trying to like kind of find up a common or an example.
Mm-hmm.
So for instance, some policies use network policy, for instance, will use labels on the pods to kind of define things, but then there isn't a way to restrict labels or make sure that a label hasn't been created somewhere else in the meantime, for instance. That would be looking at one thing.
Okay, that makes sense. Yeah. Okay. Yeah, we have similar issues there. Yeah, those types of properties are, I'd say, are generally a lot gnarlier to model. But like the escalation invariant, well, that one can also be fairly gnarly. But like some narrow definitions of that kind of thing are easier to define, I guess. It's oh yeah, go on. Sorry.
One other aspect that we get asked about, or at least in OpenShift, we get asked about is tying in with like AWS or Azure policies and those sorts of things. And it gets very complicated. We're saying, okay, escalation, but now we're going to talk about an escalation with auto scaling, which is controlled by a controller, which runs as a pod on the cluster itself.
Yep. Sorry, I'm just taking notes here. Yeah. That makes sense. Yeah, okay. And so if you're going with the OPA thing, the data log that they provide, do you know if it provides some sort of trace of execution through it in some sense? Like I looked it up, but I couldn't find.
It does. There's a decision log exposed, and I believe you can get down to the detail of line by line execution of that decision.
Oh, interesting. Cool. And so that actually represents these decisions in a form that's like semantically meaningful for the person writing the policy, as opposed to like a debug log. Is that right?
I don't know if it's like a typed output or if it. I'd have to go back and check.
That sounds interesting. I
think it does actually express it as JSON output. So I think it must have some structure to it.
Yeah, I don't know that OPA has a full semantic understanding of the objects, so much as taking in a JSON, applying a policy, getting a result.
That makes sense. Yeah.
So the decision logs are JSON output that's basically just what the input was, what the output was, and like you can add tracing to that to get more details about why the decision happened. The tracing data basically walks through everything that OPA does as it's evaluating the policy. So it's super verbose if you enable like the deepest level of explanation on it.
I see. Yeah, like what I'm trying to get at is like we had some experience with Datalog for our network modeling machinery, and the Datalog engines we were using made it pretty hard to actually trace through sort of the steps along the way, which combined with some other like scaling issues, we actually pushed us away from Datalog for that, and we moved towards sort of I guess like a very specialized type of SMT solver called Monosat. But like I guess if OPA is widely used, like as an example, the type of thing I'm talking about is, let's say you have a policy that says such and such is a member of this group of people, and also is part of this building, and you have you have some sort of entailment in your policy saying that if someone's a member of that group and someone's a member of this building, then they also gain this other power. And when I find that they have that final that power at the end there, I'm kind of curious if it can explain that I have it because I'm a member of the group and because I'm a member of that building. And it sounds like these decision logs are saying that, which is great because that was kind of a pain point with our network stuff. Does that sound like what the decision logs are doing there?
Yeah, so I think the ability to get that information as far as like output from OPA with the requests that you make to it is possible. I'm not sure. I haven't actually looked into how easy it is to like parse it without like being a human. I don't know how much of it's there like in its current form for kind of being like input for this verification engine. At a guess, it doesn't seem like it would be that hard to provide more structure around it, give that.
Yep, that makes sense. Yeah. Cool.
Within Kubernetes, we're not able to fully utilize OPA directly, or due to its data storage requirement. Kind of Kubernetes itself is limited to only etcd, basically.
Oh yeah. Okay.
But because it's kind of right now taking off as like a glue between different pieces, we do want as much as possible. We can't rely on it, but would like to be able to point people to it securely. That makes sense?
Yep. Yeah, and so the way it's usually, so what you're saying is it isn't like a first-class component of Kubernetes, but it's a little bit like Kubernetes sort of delegates permission decisions to it in some sense while it's running inside it.
Some people, that's one way it's used. Yeah.
Okay. Yeah. Well, so like ultimately, I think if you're interested in like permission, privilege escalation type questions, like it boils down to something that we've sort of started doing at AWS, but is like thinking about the actual ways one can do like a one-step escalation, and then using the reasoning engine, something like OPA or something sitting on top of it, to actually understand like the multi-step processes along that. But like there's just a lot of human modeling involved, and like, well, if you have the power to change this policy, then you have the power to escalate. If you have the power to create new principles with arbitrary powers, then you have the power to escalate, things like that. And like I don't think there's any getting around just sort of the modeling task there of just like scoping that out. Have people already talked about how that works, or like modeled that out for Kubernetes?
I don't think anyone's done anything formal. There's the main kind of access control is RBAC.
Yep.
So there's that kind of common framework, which gets a bit more complicated by the concept of service accounts.
Yep.
Which can be accessed by pods, scoped by namespaces.
Yep. And for example, like other things that would sort of fit into the thing I'm talking about are with OPA itself, for example, like in the scenario we just described of like Kubernetes delegating its decisions to OPA, like the ability to affect the OPA's execution itself is itself a privilege escalation,
Right.
And stuff like that, which like there's no way like the computer can magically figure that out unless like so we just need a sort of a framework with which to inject that kind of knowledge.
Right here, I have an example
Sure.
recently I could share. There's that chat. Where did it go? You can't find the chat. Oh, there it is. So one of the places, and this ties in with kind of the multi-tenancy, and this has come up several places, are for components that want to create components for people. For instance, the operators are meant to be kind of in this abstraction over it. The operator framework project is struggling with how they can do that well, and how can they make sure that what's created isn't above, more privileged than the user.
I see.
So that's like a specific example of where I think they would,
Yeah.
and this group would actually probably be willing to help to formally model it.
Yeah, that seems that seems like and like the language in which you model that. I mean, it ultimately just needs to be something that's translatable in some sense to like the policy engine that you're talking about. So like OPA in this case, like, because I mean ultimately it's just going to translate to queries against whatever policy engine you have and say, give me all the people who have the power to modify my OPA pod or something like that, or modify my principles, or all the people who have the power to change policies. And like, oh, sorry, was someone saying?
No, I'm just saying, yeah.
Yep. Okay. Yeah. And because OPA is data log based, it does actually seem possible to sort of define escalation in terms of like simpler rules, like those one-step rules, and then you can define sort of multi-step rules within it. I'm assuming I haven't played with OPA directly. I just saw that it was data log flavored and
Yeah, but you can compose rules upon rules within
Yeah.
Ruby. Yep.
And so you could conceivably come up with and so these rules can be expressed in sort of a query. So you could come up with like a composite rule that says can privilege escalate or something like that, and it takes in a principle and is defined recursively in terms of simpler rules.
Yeah, but yes, you can compose rules. Patrick, I'll defer to you. I believe there's no recursion per se formally. You can't recurse arbitrarily.
Right. So it's not, you can't just like arbitrarily recurse, but you can do composition of rules.
I see. Okay.
So it's
So you could manually do like n-hop rules if you wanted to do that.
right. Yeah.
I see. Okay. Yeah. So that seems like probably the direction I'd go, and like you could you can start defining some of these very very low level semantics in terms of like OPA composite rules of even just saying like listing out the individual ways someone can gain more power than they had, and then try to compose those together and construct like a sort of high level notion of privilege escalation inside OPA. And I'm talking very vaguely because I haven't actually done any of this, but I did something very similar in a different variant of Datalog where I was able to talk about these kinds of things in AWS terms.
Just out of curiosity, what were you using to build your model for that Datalog example?
Well, so as in which Datalog engine or which?
Well, we're using something like Z or something to like specify out your model.
No, I was writing it like this was like a weird homegrown thing, but like I don't know if you come across 12. It's like a proof assistant type thing, but for whatever reason someone embedded sort of Datalog into that, and like ultimately the process was me taking my knowledge about how the actual services worked, and so saying. I don't know if you've played very much with AWS roles and things like that, but you can call assume role to hop between like from one role into another role,
Right.
and they have different power levels. And you can also the roles themselves have powers to do certain things. And I was injecting effectively Datalog atoms into the system as sort of yeah, like as atoms inside Datalog, and then out of that constructing things like if a user has a power to assume role into another role, then they have the power to and they have the power to assume role from there to the next one. Then you can chain those together, and you can say, well, effectively you have the power to hop across all of them. And then you can compose that with like the power to change network configuration and the power to change policies, and then do sort of a like the recursion thing isn't fundamental, but you can, like in my setup, I was able to say, show me all the users who through any number of hops of these assume roles had the power to change my network infrastructure, for example. And it was able to query those. Now that actually worked pretty well. The painful part comes with in that kind of system comes when you start crossing it with like more advanced notions of conditions, which I think some of these policy languages are going to have. Things like, well, this user can only assume the role between the hours of 10 and 12 or something like that. And that just becomes much messier to model in a pure Datalog or Datalog flavored system. And I wish I had better advice than simplify it out for now and just like ignore it. Those kinds of things, and like produce a superset of the actual powers. Like if someone can do it under any circumstances, they can do it, and then you can filter them out later. But that's the best I could come up with in a pure Datalog system. I don't know if that helps at all, but that's sort of my experience in that space of like privilege escalation, Datalog-y types of things.
So shall we agree to start with the multi-tenancy use cases for privilege escalation? Start with OPA. What's the concrete next step we want to follow up with?
Well, I guess there'd have to be some analysis of whether it's feasible. But I mean, if you pick that as a particular use case, that's a good starting point to at least anchor that discussion. But I think, yeah, I mean, we'd have to kind of sketch out what that would look like. Can it be done in with Rego if we were going to use Rego? Can it even be expressed? And then how do we extend it if we need to, and kind of map that out? I don't know if the multi-tenancy use case is the best fit for that, or just the one that people are most interested in.
I think it's the most asked question at the moment in Kubernetes community. Like Erica just mentioned, one dimension is that traditionally how you define the multi-tenancy policies for like quota and other stuff. Another dimension is how do you define the wall when they automated populate the tenant? So where do you hit the wall? How do you describe for these set of tenant, their privilege stop here, and for those they stop somewhere farther or closer. So yeah, that'll be as far as I understand, the two things that the multi-tenancy working group actually is looking at, whether policy could help them to solve this. Because without policy, they might need to look at construct several CRDs for it's similar with the OPA gatekeeper actually. So either they will have a lot of template CRDs to help them populate the tenant custom resources, or I think they would much prefer to have a policy like helped way, so that they don't need to do that a lot of controllers to help populate the tenant resource. Yeah, that's my understanding. Yeah.
So I just got one question about privilege escalation. Are we talking about the privilege escalation of the Kubernetes user, or privilege escalation from the application user inside the pod, or which privilege
Those
escalation?
overlap. That's
Yeah.
at least when I was saying it, I was thinking of privilege escalation, starting with a user perhaps, but from there, if they can create a pod or get access to certain parts of the system, which maybe can create pods that can get access to other parts of the system, for instance.
Yeah. Okay.
Like, this might be obvious to you as Kubernetes experts, but like I think a handy way, and something that helped me was just actually constructing like a list of, I don't know, 10 or 15 like concrete ways in which this kind of stuff can actually be taken advantage of like, these are the kinds of things I'd like to catch, and this is how each of those looks in terms of policy language. As in each step along the way of like, oh, such and such was able to do exactly what Erica just said, and you know, get into the pod, and then from there have more powers or whatever it ends up being. But like, just having some nice concrete ones makes it much easier to sort of like try to generalize.
Yeah, I guess I was kind of thinking of it from a practical perspective as well, in terms of you know, pick a use case that everybody's interested in, sure. But also, I think if we were going to look at using Rego for this exercise, it'd be better to start off with a use case that already has a fairly robust set of Rego policies that are well defined and people are using today. So, for example, I look at like admission control. I think there's a fairly good knowledge base out there for using Rego for admission control policies. There may or may not be examples out there in the wild for using it for multi-tenant admission control. That I don't know. So that's all I'm saying. In terms of breaking the formal verification idea into smaller practical bits, identify a use case, but ideally one that has an already good base of Rego policies that we could start with. Otherwise, we kind of have to define whether or not the use case can be implemented in Rego first before we can start defining how we would reason over that Rego to do formal verification. Does that make sense?
Yeah, that's a good point. Whereas we might want to build up to these. Perhaps another area might be some of the more scheduling ones. That's a common one. That might be something I know people already have more concrete policies for already. For instance.
Yeah, that definitely sounds like if there is already a large body of policy, then that definitely seems much easier to engage with than if we're starting greenfield.
Okay, so should we like start with a document, or like where should we start collaborating? Or saying we meet again next week, like what? Yeah.
Yeah, I was gonna say both. Probably want a document or something somewhere. If actually anyone has a better idea than just a Google Doc, I would love to know that, because I get frustrated with Google Docs. But otherwise, we could start with a kind of brainstorming session, gathering information. Then from there, trying them out.
Is there do we have like a GitHub repo or something where you could drop like markdown documents?
We can use the SecuritySeek as a repo. We can definitely use that repo. Yeah.
Yeah, I mean, I'm happy to throw some thoughts on how we could at least look at using some sort of solver over Datalog, or sorry, Rego as Datalog. it'll be very high level hand wavy. I don't have a practical, like, here's exactly how I would do it yet. So I'm happy to throw that out as a straw man, and people can tear it apart or build on it.
That would be very helpful to me, at least. I think
Yeah,
just having something to engage with.
So one thing I'll do, like an action item. So I work with Tim and Warren and some of the other like open maintainers and like creators that like wrote Rego and stuff. So I will circle back with them. They all had conflicts for this meeting, so I'll make sure to get them involved. And I think that they would have a lot more context for how to do this kind of stuff, because I know that one of the goals of creating Rego and not just using Datalog or something for OPA was to allow these kind of use cases. So I don't have enough background to be able to tell you what exactly the difference is between, like, I haven't used Datalog, so I don't know. But they can definitely give a lot more info about that.
Great.
Okay, great. Scott, like, which project are you working with?
I'm working with Microsoft Azure.
Oh, cool.
So yeah, I met Erica briefly at KubeCon Barcelona and was like interested in the policy stuff. So I work on the OSS side, so Gatekeeper and stuff with Locky and a few other bits and pieces like that, all on the AKS side. So yeah.
Okay, fantastic.
But I'm heaps interested in the policy side of stuff. And because I'm in Australia, it actually worked out that this working group's not in the middle of the night for me. So I was like, win and win.
APAC friendly.
Yeah, it's APAC friendly. I said to Erica, is it going to be APAC friendly? She said, actually, I think this one might be. I was like, holy moly, this is awesome.
This might be the only one. Yeah.
I think it might be. Yeah. So yeah, okay. So sorry, I joined late, but yeah, that's a little bit about me. I'm predominantly working on AKS and the Microsoft side of Kubernetes stuff.
Okay, great. Okay, so let me start figuring out like how to utilize the security SIG repo. And Robert and Patrick, if you have like any other high-level strawman, just feel free to propose, and so we can schedule meeting next week or the one next week to sort of begin the jumpstart the discussion. Does that sound good?
Yes. Did we say, you said we'll just meet the same time next week to do the?
Yeah, I mean, if we have like something new to discuss, then we just continue on a weekly basis, or could skip the next week. Like, we can discuss multi-tenancy with E3 next week, because that's another like big area.
Yes.
Okay. So Dan and Scott, if you like hop on the Slack channel or join the Google group, I think you can like participate in the discussion or like receive notifications. Yeah.
Which Slack is this? Is this on the standard Kubernetes Slack, or?
Yeah. WG dash policy.
Yeah, I'm on the Slack. I'm Scotty C.
Cool.
I asked for the previous meetings and caught up on all the previous meetings and bits and pieces like that.
Cool.
I have been part of the Slack. I don't know if I'm in it right now, but I will find my way over there.
Too many Slacks, I understand.
Yeah.
Okay, great. Thank you, guys. I think we can conclude the meeting for today. I will upload the recording to YouTube as usual. And if you are interested in our past meetings, you kind of just search Kubernetes policy working group on YouTube. That'll show like all the upload I've already done. Okay.
Makes sense. Great.
Awesome.
Okay. Thank you so much.
Thanks, everyone.
See you next week.
Thanks, everyone.
Thank you.
See ya.
Bye.
Thanks. Bye-bye.